Okay, started recording, guys. So we are now looking at the revision. Okay. Okay, who came late? This one. This is the revision, right? The same revision I gave you on 20, okay? Okay. So, how's everybody feeling about the revision? We're all feeling good.
It's highly better.
Exactly.
Just one or two challenges
That we can work on. Right? Which is why we're here today to work on it. And yeah. How's it? How are you? Good, good. Take on the vision sheet. Welcome.
I can taste my son. I can taste the drink.
Where is the register?
Register is going around somewhere. Somewhere. Oh, there's Jabba. We'll have this. Okay, looking at your revision for test 1. So, okay, let's go to the definitions, right? Let's just get that out of the way. For your resultant velocity, what's the definition? That's not.
There will be a single velocity. There will be a single velocity that would replace the effect of
Two or
two or more
velocities.
X is the point of object.
Yeah, so I got it as the resultant
I check the mark the markings.
Because of you.
But you didn't say it says velocity.
Thank you.
And this velocity not affected.
But it's resultant velocity. Okay, so the resultant is the resultant of two or more vectors, which is a single vector which can replace the two or more vectors and still do the same work, right? So in the case of, like, you know, when you have the velocity of A and the velocity of B, this here could replace these two forces and still do the same thing that they would do, right?
Like question 2.
Yeah. Okay.
That was question 2, yes. Which resultant velocity, you know, the test. Yeah.
We're gonna come to that. We're gonna come to that. Right?
I got it wrong.
So, yeah, so everybody's working with it.
Joe. First.
The sum of objects is the sum of its individual.
Can I address this with magnitude and tangent?
Yeah.
Okay.
This means that.
Yes.
You don't need to give an example of what it is. You just needed to say that it's the sum of all the velocities that act on a component as one component. So let's take how we said over there, two or more vectors. It replaces the two or more vectors into one vector. Okay. Then, the definitions I don't have to take. I'm going to send you my solution sheet to
Oh, that.
yes. Okay.
That's nice.
So I'll send it to you after we do this. So we need to go through it first and then. Right? Okay. What's the second one? Distance.
But that is the sum of the velocities, huh?
It's the but you need, the main thing is it's the sum of two or more velocities that can be replaced by one.
Okay.
Okay? So yeah.
And what if you put formula there?
It's what?
But if you say, okay, velocities or vector or forces, it's all still the same.
Yeah. Okay, you can say it's the sum of two or more forces being replaced by one force or something. Right?
Yeah.
Main thing is the two or more being replaced by one.
No, it's a serious question, right? Just say you have, velocity is distance over time, displacement over time, right? What if you say, what is velocity, right? And you say it's the displacement over time.
That's right.
That's right.
That's right.
So, okay, you can use the formula in slides.
That's how you get definitions.
Yeah, you take
but
a formula.
See, resultant is
Okay, no, that's
there's not a
good, yeah.
formula for
Yeah.
resultant. Resultant is something that you have to do all the calculations to get to your resultant. Right? But remember, it's just one force replacing two forces, two or more forces.
So, like distance will be the velocity with respect to time. Specifically.
No, you don't do it again. You don't swap a formula around to get something like that.
But as you drew it, the drawing actually basically, if you write it in this case, like a drawing of two forces, X and one,
Yeah.
combining them.
You saying give me that as an answer?
No. What I'm saying is that's basically how you can think of it.
Yeah. That's exactly what the definition
Exactly, you're
is.
saying formula, write the formula down. That's how you think. Same
But see, because this is definition questions,
Yeah.
you have to write down the words of what each is.
Okay.
Okay? So distance is the change in position of an object, which includes the total distance covered. Okay? So this is the change in
Distance.
position. Okay, that's straightforward. Displacement is the.
You're giving a definition of distance, but on your definition you got distance as well.
Yeah, but this here, you see, the main thing is it's change in position of an object, right?
Yeah.
And then this part here where I'm saying which includes the total distance covered. Remember for displacement, right? Displacement is the shortest distance between 2 points,
Yes.
right? So if you have point A and point B, right?
Right.
This here is your displacement. Shortest distance between the 2 points in a straight line, right? Distance could be
Total distance covered.
you doing all of that,
Yeah.
right? So distance is the change in position of an object. The change in position will be from A to B, right? Position being where it is to where it is now, which includes the total distance covered, which means it includes everywhere that it went. The difference between that and displacement is the shortest distance between.
So if I was to say that distance is the total length traveled by an object and it only has magnitude, will I be right?
Yeah, that's it.
On the
That's
mid-
fine, because you covered the main thing is the
So
total.
write it out.
Yeah. But that sounds like a
Let's
Google,
just-
like a Google
Let's just go on.
definition. Google definition.
Okay, so displacement, like we said, is the shortest.
1.82.
Traveled
I think Jeffrey got the answers from the memo from the
fast rate.
Right.
Yeah. Okay. The other two, angular velocity. Right? Angular velocity is just the rate of angular displacement. What does that mean? The formula.
I know the formula. So I said angular velocity is the displacement of object, but by use of time.
Same thing, right? Because remember, angular velocity, as much as it's equal to 2 pi n, right? There's also a formula where it's equal to that, right? Now remember, anything over time is the rate of something. It's per second, per minute, per. So this is angular displacement. So it's the rate of angular displacement. That's it.
The rate of a change by which angle is formed.
Yeah, that's the same.
Also
It's the same, because angular displacement is that angle but in radians. Okay? Okay, so this is the rate of angular displacement.
Since you can use it like that.
Now what you do is on birds and saying
Yes, you can't. No, let's clear it up, right? So we can use that formula if it's the formula is like that, right? So if you're finding out angular velocity, the formula is angular displacement over time, right? So you can use it perfectly. However, if they're asking you what's angular displacement, you can't say angular displacement is.
No, you can't rearrange that
rearrange
formula because remember this formula is specific for angular velocity.
Yeah.
Right? This is your angular velocity formula. Right? Because using the two things you're going to get the units of. But angular displacement can be used in multiple formulas. It can be used in other stuff. That angular displacement is just like a distance. Okay, so you can't rearrange formula. It's like how the standard formula is. That's how we will
Okay.
go. Right? Is it fine? Is it okay?
no, I'm fine. He's got the issue of me.
Yeah. Okay. Then angular acceleration is the rate of angular velocity in radians per second. That's fine with it. Okay. Yeah. Okay, so that's your definitions. Is everybody fine with that?
Yeah.
Did we all get 100% for that?
Yeah.
10 marks. As long as it covers the gist of what all this is, right? Okay, now let's get to the good stuff. Right?
Yeah.
Good stuff.
Nice.
Let's get to the good stuff. Right?
Yes.
Hey, look at Oliver, what dirty looks like. This side of the classroom. What? Did I know you pick up his head? I had to turn my head and I looked at it. Right?
I can't put a balcony at home.
Okay, can I take this again?
Yeah.
So,
Hey. So the question 2 is the
I know you're all waiting to get the question too.
Yeah. Question 2 is the hardest of them all.
It's not, but it's not hard. But you'll see. Okay, let's look at this first one, right? So they tell you that a bus and a truck leave simultaneously from a fork in the road. The truck travels northeast. So it's traveling northeast, it's moving in the northeastern direction. At a velocity of 85 kilometers per hour. The bus travels directly east.
Just took a bus.
104 kilometers
Per hour.
per hour. Right? Calculate the velocity of the truck relative to the bus. Right? This is all that was given to us. We never missed out anything. This is our information. How will we start this now? And the first thing we do when we come to a question like this,
Your horizontal component.
before you even come to that part. Before you even come to that part.
Make sure it's directions.
Directions, right? So, let's say this is positive, positive, negative, negative. Right, now we get, okay? Now we can see that we have something that's moving obviously at an angle and then something that's moving along the horizontal. Now, for this question, looking at this, we know that we're going to need to break this up into its vertical and horizontal components, right?
Yeah.
We need two things to do that. We need its magnitude and we need its angle. Right? We only got magnitude, we weren't given an angle. So what can we do?
You assume it's 45.
We can assume,
We assume.
that it's 45. Right?
Yeah.
So we're assuming here 45. Right? Okay, let me take out the assume because we're going to write it.
Yeah,
First thing just
it's more like when they're saying, so there's like
it's moving
like
in
a
that
pivot,
direction. Yeah. It's like we just take it as it's moving dead center between the two.
Yeah.
North and east, right? 45. Hundreds, right? We got that. We know what we need to work out. How do we start?
Velocity of t relative to the ground. along x-axis is equal to 85 cos 45 degrees.
Right. So we're gonna work out the vertical and horizontal component for the truck, vertical and horizontal component for the bus. So the vertical component for the truck along your relative to the ground along your x-axis would be equal to its magnitude. What 45? Cos 45, right? So this would be 85 cos 45. And because this is moving towards the right, it's a positive 85, right? Okay, this is equal to
60.14 kilometers per second.
Hour.
Per hour.
Per hour, right?
Yeah.
Then we work out the velocity of the truck relative to the ground along your y-axis. It's going to be 85 sine 45. So this will also be 60.104 kilometers per hour. Right. Then we're going to do velocity of the bus relative to the ground along your x-axis. It's just positive 104 because this is moving to the right. Okay, so this is 104 kilometers per hour. Velocity of the bus relative to the ground on the y-axis is
0.
Fine with that, right?
Yes.
Using that now, we're going to have to work out the velocity of the truck relative to the bus along your x-axis. Okay, so we say velocity of your truck relative to the bus along your x-axis is equal to
velocity of the truck relative to the ground along x-axis plus velocity of the ground relative to the bus along x-axis.
Right. Now we're going to make both relative to the same term, which is your ground.
For number 2, I want you to be saying all that.
Right, you all understand how we got you?
Yes.
Right. So, truck relative to the ground along your x-axis is 60.104 minus
104.
104. This is equal to
Minus
43.896
kilometers per hour.
kilometers per. Then we're going to work out the velocity of the truck relative to the bus along your y-axis. This is
velocity of the truck relative to the bus along y-axis plus velocity of the ground relative to the bus along y-axis.
right. Then we make both relative to the same term. Right. Substitute your values. This will be
60.104 minus 0.
60.104 kilometers per hour. Okay, now we have your vertical component, you have your horizontal component. If you have to draw that, your x component is moving in a negative direction and your y is moving in a positive direction. Okay, so this here is 43.896, this is 60.104. If both are pulling that way, your resultant is going to be in this direction. Okay, so this here will be the velocity of the truck relative to the bus. Right? Okay, so to work that out, velocity of the truck relative to the bus squared is equal to velocity of the truck relative to bus along your x-axis squared plus velocity of the truck relative to the bus along your y-axis squared. Right? And we'll say this is our A. Okay, so this would be equal to 896 squared plus 60.104 squared, and this is
427 kilometers per hour.
Right. Now we just need to work out the angle. So we know tan of the angle will be equal to its opposite over adjacent, right? Opposite in this case would be the velocity of the truck relative to the bus along your y-axis. This would be x-axis, right? This is equal to tan to the minus 1 of 60.104, 43.896.
minus 43.
Minus
Minus 43.
Why minus?
You know?
No.
The minus
We don't put the minus 7 because remember.
50.858.
No, I'm saying you saying put minus it.
Yeah.
No, because remember in these questions here, negative and positive is for direction. So you see when I drew this arrow, I drew it that way. So that covered your negative. So we'll just use the value as a positive. It's like an absolute value of it, right?
Okay.
So this comes to
Positive.
53.858
degrees, right? So then the main thing now, your final answer, how you would write it, you would say the velocity of the truck relative to the bus is equal to 74.427 kilometers per hour.
West,
West.
53.858 north.
Degrees north, right?
How many marks here?
5.
Five. What a lot.
Does anybody have any issues with that? No. You saw how fast we answered it too. How fast we answered it?
Another question. When it says velocity, right? The question, it just says velocity. Does that mean the velocity and direction? Or just velocity?
Just velocity.
No, because yeah, I see we did direction as well.
It only asked the velocity. It didn't ask
Then what's the direction? That's what I'm asking.
Oh,
But it's fine. I think we
no, but you would know, but you would have to because you need to say yeah because it's relative to the bus. You need to say where is it, how, at what point is
It might not
relative.
say direction,
But you need to
it sounds like
answer.
it's still
Yes, it's
direction.
related to the bus.
Okay.
Okay,
Alright.
so we all good with this. Anybody has any issues? Fine.
Yeah, I don't know. I actually got it right on the direction part, but I don't know how.
You know how you did.
Yeah.
Just do the same thing tomorrow. Just do the same thing. Don't worry how you got to it, just get to it, right?
Yeah.
Okay, I'm checking this out, right?
Okay.
Yeah, not tomorrow, Saturday.
Yeah.
Right, let's do everybody's favorite question. Right, there's a lot of catches in this question. Let's see if anybody caught it, right? Okay. So, an aeroplane flies to its destination 300 kilometers directly east of its starting point. Right? The pilot wants to complete the flight in 50 minutes. Before we carry on any further, what was just given to us?
The resultant velocity.
How do we know it was the result?
Because he wants to get there. 300.
So from his start point to his end point, that's where this plane needs to go. Regardless of whatever happens to the plane, this plane needs to go from here to there. Which means they gave you the resultant. Okay? So if you are to draw it, this plane is going to move directly east. Okay? And then they give you... Okay, so I'm just going to call this your resultant line, right?
Yeah.
And they give you the distance is equal to 300 meters. And the time...
Kilometers.
Sorry.
Yes, Piano catches in this question, huh?
Yeah, you carry on. See you answer this. Okay, time is equal to 50 minutes. Right? Right. Then they tell you that there is a southwesterly wind blowing at 10 meters per second. Before we carry on, right? Did anybody look at the picture I sent you on the group?
Yes.
Right? Remember we were talking about catchwords and stuff where they tell you the tailwind, headwind, all that sort of things?
Yeah.
If the word ends in early, like southerly, northerly, easterly, westerly, it means that it's blowing from that direction to the other direction. So if I tell you an easterly wind is blowing, it's coming from the east blowing towards the west, this way, right? So southwesterly means that it's coming from the south, but it's blowing towards the northeasterly, right? So if you had to draw it, this here is southwesterly. But can you see which way the arrow is going? Right? So it means at some point this wind is going to go something. We understand that? Okay, good. So this wind is blowing at a velocity of 10 meters per second. Calculate the velocity of the aeroplane and the direction of the flight. So what they basically want to work out is this plane is going to fly, right? This wind is going to hit the plane. How must this plane, well, what direction must this plane be flying in so that when the wind hits the plane, it still flies to its destination there. Okay? We all understand that?
Yeah.
Is anybody confused? Fine? Okay, right. Good. Now, how you would start this off is, firstly you need to figure out what direction must this plane be flying in, right? Or where will you draw your aeroplane line? Okay? So don't look at this part. I want you to look at here. Right? Remember when we were talking about resultants, right? And we said that resultant is the one force that will replace the sum of two forces. Okay? So if this is one of the forces, where must the other force be for this resultant line to come out there?
So it needs to be parallel with the line. If you join the two dots or the arrows, it should be parallel at the bottom.
Oh, you mean like if you join from here to here,
Yeah.
it should be the same thing that you would draw here. Okay? So this line here would be the velocity of your aeroplane. Do we understand that? So if you look at it now, right? If Bilal is pulling at this end, and if Earl is pulling at this end, whatever they pull in here will move like that. Does it make sense?
Yeah, okay.
Everybody understand that? Okay? So now we visualized what was given to us. Now they want to know what is this velocity, and then obviously the angle will be formed here, so we need to work out that. Cool. Okay. So this question here, we will start it like how we would start any normal question, right? We'll get our direction, so we know that up is positive, down is negative, right is positive, left is negative. Now resultant velocities. Okay? How would we normally go about solving for a resultant velocity? So you'll work out the sum of your vertical components, you'll work out the sum of your horizontal components. Using that, you'll get your triangle for theorem of Pythagoras, and then you would solve, right? So let's start with that first part. Okay, firstly, let's work this out, right? So your resultant will be equal to the distance over time, right? So it's going to be equal to 300 over 50. So this is 300 kilometers over 50 minutes.
The velocity is distance over time.
What?
Yeah.
Anything?
Yeah, no, same.
Oh yeah, velocity is distance over time. You can look at it by the units, right? See, like this is velocity meters per second, distance over time, right?
Yeah.
So now you just need to convert this into meters per second.
Yeah.
Okay, so you would say 1 kilometer is equal to 1,000 meters. So we cover the meters part, get this to seconds. 1 minute is equal to 60 seconds. Right? So this here is equal to?
300,000.
100.
So this is 300 times 1,000 all over
100 meters
50
per second.
times 60. Right?
Yeah.
So this is 100 meters per second.
Yeah.
We okay with that?
Yeah.
Right? So I'm just going to write it here, okay? This is equal to 100 meters per second.
How many marks for that?
This?
Yeah.
1. It's
One.
just,
Another
it's
one.
just a conversion.
Free one. It's a free one.
It's a free one. Fine. You're going to see now, it's not as bad as you're thinking, right? So remember I said now, okay? This line here, you'll know, has a vertical horizontal component. This line here has a vertical horizontal component. We use these two lines here to eventually solve for that. Okay? So, your sum of your vertical components will be equal to this vertical component plus this vertical component. We need to make an assumption here of 45 degrees.
That was another trick there. I think that's what stopped me.
Yeah, because, okay, see, I never draw it with the axis, right? But, oh shit, what?
Yeah.
If you look at the thing like that, right? Can you do anything with this question without having the 45 degrees?
No.
You can't do anything, right? So you have to make the assumption that it's 45 degrees. I'll give you another hint for tomorrow's test. All your questions with kinematics, you're going to have to make the assumption for the angle, right? Okay, when you're solving phase. Okay. So now, we pretty much got everything we need, right? So, if you had to do this part here, you would say that the velocity, the sum of the vertical components would be equal to VW sine of the angle for this, right?
Yeah.
Plus velocity of your aeroplane sine of whatever that angle is. Right?
Yeah, that's yeah.
Must I show it on this?
Yeah, but that VA, so what shall you do now is you sign. So it'll be
Okay.
minus.
I'm taking this out, right? Because we know
Yeah,
this,
take
right?
all that stuff
I'm
out.
taking this out. Okay.
So won't that be minus?
Yeah, I'm
VA?
coming to that, right? But I'm just showing that the sum of the vertical components is going to be this, which is that line there, plus this, which is this line here. Fine. Your vertical components, remember, this here is, this part here comes from the resultant plane. Yes? Does the resultant plane have a vertical component?
No.
No.
No. So what would be the vertical component?
Zero.
It's going to be 0. Okay? Equal to VW sine theta. Right? So VW, velocity of the wind, we're going to need to see now whether it's a positive or negative value. Is this line moving up or down?
Up.
Moving up.
Up. So it's going to be a positive magnitude. So this would be 10 sine 45. Right? Plus. Okay, so now your VA, velocity of your aeroplane, is the magnitude going to be a positive or negative?
Negative.
Why? Because the line is moving down. So this here would be negative VA sine of whatever this angle is. Okay? So if I take this across, it will become positive VA sine of the angle. Yes? Yes. So this would be VA sine of the angle is equal to, what's this?
7.071
Meters per. Are we fine?
Yeah.
No, I'm not sure.
What?
Oh, so somebody's thinking. You see that velocity of the what's W? W is the wind, right? I think the whole idea is which angles you take, right? So if that's 45, you're working out the components on the side here, right? So I took that line there and I drew it up on the top, right? So the velocity of water was actually on the top, right?
I mean,
Sorry, wind, right? Drew the line up on the top.
you should still come to something.
Which angle would you take?
It's like
It's the same angle. I mean, opposite.
it's going to be 45 here, it's 45 there. If you come here, it's going to be 45, it's going to be 45.
Yeah.
They never gave you a different, like if this was 33, right? If this was 33,
Then
33 plus 90 is 123,
Yeah, right?
right? This remaining part, because remember this is a straight line,
Yeah.
will have to be 180 minus that value, which will be 66.
Yeah.
So in the instances, whatever is here,
Yeah.
the opposite would be that same value, and whatever's here, the opposite would be.
But you would have taken the one closest to the vertical axis for that.
Oh, you're talking about if you're working out your components.
Yeah.
Always
Always
keep
take
your
one
angles closer to your x-axis.
Closest to that.
X-axis. So if this is your plane,
I think that's where I was getting I mean,
right? And if this here is your lines, right? Always take this angle here. That's closer to your x components, right? Why we do this? Because it will keep consistency where if you're working out your vertical component, you'll always say sine of the angle. If you're working out your horizontal component, you'll always say cos of your angle.
makes sense.
Right? Be good. So now you find this one.
Yeah. Because that's why I ended up with the cos and the sine.
See, because you took the angle from the other side.
Yeah.
And it does mess you up a bit as you go along because you try to keep consistency is always nice, right?
But I think that's a cheat. That was a
But
cheat.
the answer will be the same.
You still no, you are going to come. It's
Same
just
answer.
in this instance here, because we were lucky it was 45. But in another case where it was a different angle, you're going to end up with a different angle. What is right? You should have still got the same thing.
Same
I
answer,
didn't
but
take a direction.
the sign will be
The
different.
sign would
The
be
sign will be
sign change.
The negative.
The minus.
Oh yeah. See that you have
That's
to
right.
make a note of that, right? Okay. So we're still good, right?
Yeah.
No issues. Don't take it on yet. Just follow that, and then when I'm done, I'll give you a time to take it on. Okay. So sum of your horizontal components would be equal to, it's going to be VW cos of the angle plus VA cos of the angle. We all understand how we got that?
Yeah.
Yes?
Mm-hmm.
We all fine, right? For which, this one, yeah? Okay, so remember we said that for all vertical components, you'd always use sine. So now because we're working on horizontal components, we're always using.
I've got a false up.
You move that.
I mean, it's stressing for your test, huh?
Alright, so we'll do revision tomorrow. This also.
That's what you want.
No, I don't know. Today
That's easy.
It's looking like pages and pages.
For tomorrow.
no. Yeah, the main paper.
What's that?
Yeah, no, we'll do the revision tomorrow. I'll send something out and then we're going to discuss it tomorrow and Friday.
Okay. So you understand, right? Okay. Now remember I said that this horizontal component, the sum of the horizontal component, is your horizontal component for your resultant. Our resultant only has a horizontal component, yes? Yes. So the value over there would be what? 100, positive 100 because it's moving to the right. So let's say it's 100 equal to your value for VW is moving to the right or left? For the velocity of the wind, is moving to the right or left?
Right.
Right. Because see the arrow which way?
Yeah.
Let's go to
To
the
that way. Right? So it's going to be a positive value. So this would be 10 cos of 45 plus VA. It'll be positive VA, right? Because the line is still moving to the right. You understand the part?
Yeah.
Okay? Cos of the angle. Right, everybody's fine with that? Okay? This here is going to work out to 7.071 plus VA cos of the angle. And then you take it across, you end up with 92.
Stop.
929.
Stop there.
929 equal to VA cos of the angle.
Get a concept and work it out.
So I never like to work.
I'm going to do the 2.5. Pretty much, yeah. Yes.
Okay. Is anybody so far confused with what I did?
So Abby, send me example.
Abby.
It's like Abby, so I'm thinking of Abby. If we drew the wind in the first plane,
First part.
the first quadrant plane, would that still be right? We just
Because you'll
use a
still
different
get the same
angle,
value.
but we should get the same
It's still have the same.
You're still getting the same
because
answer.
we're saying that it's going there, so we're looking there.
Because remember, this arrow would still be pointing there.
It's the same
This
force.
angle would still be what this angle is.
It's the same force.
This magnitude would still be the same magnitude.
Yeah.
So your direction, magnitude, angle, same. Okay? Is that fine? So far, where we are?
That's the important one because I think most of us, the way we understand it now, is we put it in that way. Yeah.
That's fine. That's perfectly fine, right? That's why I drew it with the dotted line because I know that some of you will do it like that, right? So, where we are now?
The 92.9, is that?
I'm coming to that part, right? So, we all know, we fine.
Yeah.
This is where I got
Then you
confused.
don't know what to do now.
Because you got two variables, you got four variables. You got VA.
No, but see, that's where you're wrong, right? See, what do we have now, right? What is these two values that we just worked out?
Horizontal and your vertical.
Vertical of what?
X and your
The
vertical.
aeroplane, right? So if you look at it,
The aeroplane.
this here will be your vertical component. What is this? This is VA sine of the angle, isn't it?
Yeah.
Right. And this line here is VA cos of the angle. Yes?
Yeah.
VA sine of the angle, we got a value for it. We got 7.071. This here we got 92.929. Right? Look at this triangle and tell me about this triangle. Tell me something you can say about this triangle. What type of triangle is it?
Pythagoras.
It's a right angle triangle. So you can use theorem of Pythagoras to solve for that. Right? So how would you do that? You would say VA is equal to VA squared is equal to VA sine of the angle squared plus VA cos of the angle squared. Because remember, this is the vertical component, this is the horizontal component. Okay? So this here, VA, Bilal, you're looking very sad over there. Right? VA sine of the angle is 7.071 squared, because that's the value of that. Right? Plus 92.929 squared, which is
93,198.
Is anybody confused with what I just did there?
Yeah.
Which-
I don't know how.
You don't know how?
Yeah, I heard right, but I don't know how.
Please on Saturday do this. I don't care how, whether you tell me you don't even know, just get to there, right? Okay,
No,
but
definitely than what you got there.
you still got. Oh no, don't do that. Don't do that. Just
Try this way.
No, I got all everything, but
but you still can't remember how you did it.
no, I can't remember.
Right.
What you just
And doesn't make sense. But
You didn't do
I
it.
don't know that makes sense, but I got the right answers.
Okay.
Yeah,
Up till here we all understand, right?
yeah.
Are we confused about that? How I got to here?
Yes, this is the side that
Okay.
we're confused.
Do you understand what I meant by when I did this and this?
When you're explaining now, we can see, but
No, but I'm saying, but like now at this moment, do you understand what this line is, what this is, and these values?
yes, we
Because
can
see what we worked out
Yeah.
there? How you would have, if you were given this value, and if you were given this value. Yeah? To solve for the horizontal component, we would have said VA, cos of the angle, to give you that. And to solve for the horizontal component, the vertical component, we would have said VA, sine of the angle. Right? This time, we worked out this value and this value, and we want to solve for this value. Remember, this triangle here is a right angle triangle. So we can use theorem of Pythagoras to solve for this, because we know the horizontal component and we know the vertical component. So that's what I did there. Are we okay with it?
Yeah, the question. The one that 92.9, is that not negative?
No.
Yeah, okay. I don't know. I always,
Yeah, but even if it's
It was
negative,
subset.
it's going to be squared and.
I don't split up. I know it can't be the right answer, but it's basically negative in
No, but it won't be it.
Right.
See, your horizontal component is 100, right? Positive 100.
Yeah.
Okay? When this number comes out here, you're going to end up with 100 minus 7.071 because you took that across. So at no point it would be a negative.
Okay. But in the
I'm saying specifically to this question.
Okay.
Right?
But you're gonna square it. It should never be
No, you square it, it's fine. The one still comes out right. I had a negative, I think equal is.
And also to remember, right? This, we should be talking about this number, right?
Yeah.
This number is the horizontal component of this line here. Right? If you're looking at this line, its horizontal component is moving to the right. You cannot get a negative number for its horizontal component because the resultant of that line is moving to
Oh, it's still
the
positive.
right.
So there's a 7, but then the 7 wouldn't. The 7 also would be.
The 7 is also a positive value because this line is also moving to the right.
Yeah, but the 7 is the vertical component. The 7 is the
seven?
vertical component.
You're saying the VA sine of
Oh, no.
the angle should be minus
It should be in the
7.071.
negative quadrant. On the
Right.
y.
Talk about this line.
Yeah.
The
No,
707.
but remember something, this line, vertical component, we only worry about up or down. Right? So this line is moving up or down?
up.
Up. So its vertical component supposed to come out as a positive value, which is what its vertical component came out as.
Okay. Okay.
Because this line was moving down, its vertical component would have came out to a negative value. So that's why I got negative VA side there, but we took the negative across. So it became
Okay.
I thought it was negative.
the vertical component of this.
Because it moved.
Yes.
Yeah.
That's negative. That's where the arrow is coming.
Yeah, that's
down.
Yeah, that's
Okay.
beautiful.
But because remember I told you positive and negative is for direction.
Yeah.
So that's how we got that.
Okay.
So guys, so far we're okay.
Yeah.
Not difficult. Not impossible.
Don't thinking, yeah.
Thinking of
Yeah.
Yes, but see that's the thing. They're gonna do that to you because they want to see that you can apply what you learned. It's not a straightforward thing where we give you everything and you have to work it out. Because remember, all they gave us was this line here and that line there. That's it. That's all they gave us. From there, we built all of these things up. Right? Now, the last thing we need to do is solve for the angle. Now, on a normal case, how would you solve for this angle? Tan, right?
Yeah.
Tan is equal to?
Opposite over adjacent.
Tan is equal to opposite over adjacent. We know opposite, we know adjacent. So what we can do, we can solve for the angle, right? So tan of this angle is equal to VA sine all over VA cos. We know those values, right? So the angle is equal to 7.071 all over 92. 929, which is equal to 4.351 degrees. So therefore, your final answer for the velocity of the aeroplane is equal to 93.198 meters per second, and where your angle is found?
Down. So it will be east,
East,
4.351 south.
right?
1 mark for that. How many marks? 5.
Fine.
I got 1.
How many of you got it right?
Yeah.
Kaya, what point? I mean, what point did you? Because I saw you were going yes when I came here.
Yeah.
Yes when I came here. Then I think you went yes so yeah.
Yeah.
So the problem is that
Our issue was when because I was doing it with Zama and Cindy. So when we were doing it, that where we got it wrong was on the drawing. So that's changed everything.
Because and also guys see with a type of question like this, right? If in an exam they give you something that we never saw this before, but in your mind now you figure out okay this is your resultant and they gave you this, they want to work on this, right? Try to work on what you can. Okay? So follow your procedure like how you normally would. You see like how I asked you for resultant velocity, how would we do it? We will work on the sum of the verticals, sum of your horizontals, which we started with. And then we wrote down what we know. We know that the vertical component for the resultant is 0. We know that this plus this will give you the vertical component of your resultant. And then we solve. And then we see, okay, we came to this point here. Can we do anything further than this? No, right? Because we don't know the angle, we don't know that. Okay, so fine, leave it there, right? Move on to your horizontal component, okay? Do the same thing. Then write it down. Now you know that you worked out your horizontal component and your vertical component. That's all we need after that to solve for any resultant line. Because we use theorem of Pythagoras for the magnitude, and then we use tan to work out the angle. So once you have done this and this, and if you wrote it down there, the more you stare at it for like 10-15 minutes, you have realized theorem of Pythagoras done, and you would have got it.
Okay, so this question. That it means 4 degrees down, am I right?
It's this angle.
Yeah. Okay.
Okay. So
That's easy.
because remember this wind's magnitude compared to like aeroplane's magnitude.
No, makes sense.
Right?
Makes sense.
It has to. It's not going to push it a bit. It's
Yeah,
not.
but the plane doesn't have to go that far. It's actually less than what its actual speed required because the wind's pushing it.
Yeah.
And then the angle is that it's compensating for the wind going that direction. That's 4 degrees.
Yeah. And remember, it's pushing it along the horizontal.
Yeah,
so that's
yeah.
how you got that little boost to push you up to 100.
Yeah.
So if I were to use that the other angle, that the one that closer to the y-axis, it would have been that 360.
Talking here or
yeah.
Yeah.
That one on the fourth part.
Yeah.
So it would have been 360 minus whatever answer we got there.
360, just 90 minus it. To get this angle here,
Yeah.
it would be 90 minus 4.351. So you would have ended up with like 85.759.
No, what is saying in south?
65.
South
South
east.
Yes. Yes. It's
So
all
why-
right.
Yeah. So I'm saying to get this value would be 90 minus that,
Yeah.
but your answer would have been south,
South.
like whatever the number worked out to,
Yeah.
east.
Then
okay, I hear what you're saying, but I'm a bit confused because for me, that other angle is not only that part there, that 90 minus.
It's all of this.
he's
all
not
of
seeing,
it.
he's
No,
not
but
seeing.
see, remember, this is north,
Mhm.
south,
West,
west,
east.
east, right?
Mhm.
When you do these two parts here,
Mhm.
where you show what it lies between,
Oh,
Yeah.
you're giving
It's
which
only 90
quadrant
points.
it's in.
Yeah.
So you'll start at that quadrant, okay, with that much off this line and then done. Okay, so, wasn't that?
Yeah. So,
For me, it's the signs.
Yeah, the sign will be.
And like for the horizontal component, you have to say whether it's positive or negative.
At this point here, see when you come here,
Mhm.
when you're deciding when you're substituting your value, you need to see where they, even if you show the negative sign here, it's fine. Because you know you said over there, right? It's fine because you want to see it same time. Just cover the whole lot. That's fine. Okay. You had a question?
I'm trying to find out how to solve that R.
This one?
Yeah.
Okay, so the two values they gave us, right? The velocity is equal to distance over 10, right? The value that they gave us, or these two values that they gave us, the 300 and the 50, is for your resultant velocity. So it's your resultant velocity. Okay? So that's why I said 300 over 50, which would have gave you like 6 kilometers per minute.
Yeah. So
This
minutes.
minute, right? So then from there, you would have converted it to
Minutes per second.
meters per second. And then you would have ended up with this 100 meters per second.
maybe
6 kilometers
what you
times
could do is,
1,000
the same thing what you did the other side, right? So take
divided by 6.
you want basically meters, right? And you
So
want
multiply on the
seconds.
top
So take the 30
and you divide at the
kilometers,
bottom.
multiply by 1,000, so it becomes 300,000 over.
Yeah, even if you did it, if you converted
At the bottom.
individually, like
Individually.
before you
And
divide
And
it,
then
that's
like,
fine.
like fractions.
So
yes.
all the
Yeah.
things from the top you multiply, all the things at the bottom you divide.
That's what I did because it's yeah.
Now, I see
Are you okay? Does that answer your
I see
question?
why Unene getting confused.
It's how
Because
to- it's the
in
meaning
there,
of how
everything
to
is
combine.
together, but she wants to eat it individually. But yeah,
But yeah, which is what that
kilometers
is there.
That's what I'm
and
saying.
meters can.
Convert
6
kilometers into meters.
10,000.
Divided by 60.
See,
Convert your kilometers. So take the 300 kilometers and make it into meters.
Oh, you're confused about
Yeah.
what you do with this?
So, Nene,
Yeah.
Oh,
the
okay.
units always have to be in meters and seconds. So, because the guy was kilometers and minutes, we have to convert both of
No,
them.
she's confused when you come to this
Yes,
part here, right?
As long
So
as
how
it's
you
the
write
same
it
units.
out
So
is,
you could have
if it's on the same line,
kilometers.
you multiply it,
Okay, either way.
right? If it's one above the other, you divide it. Okay, so this
want to keep it.
Always be in
You
meters.
always want to.
middle line here is basically division, and these lines here are
Yeah, but
multiplication.
But it's same.
Okay, so if you're putting it in a calculator, you would have put 300 multiplied by 1,000 multiplied by 1. But we don't show 1 because 1 anytime itself is 1, right? And in the bottom, it would have been
93.
50,
Would they allow you to have it in
One.
meters?
60.
The answer.
That's how you're putting the calculation. Does that answer your question?
Let's convert.
One more question.
Are you sure? But you can do what Earl said, right? Earl said that you convert this to meters first, like how you would normally, and then just divide it. Distance over time.
So make it into like actual calculation.
Yeah, and then just say distance over
Like
time.
fraction is simplified again.
Okay. Okay.
Yeah. But then, if you convert it to meters per minute, like how you say, then the wind has to be converted.
No, meters per minute, meters per second. So take 300,000 and you take 50 minutes times 6, so it becomes 300,000 over 3,000, right? And you take out the zeros and eventually you get 250. That's what
You just say individually do your conversion, then divide.
It's better to keep everything in the standard units.
Yeah.
No, what he's saying is...
Jeff, so the only reason you convert it is because that's in meters per second.
Yeah. And we're keeping it consistent.
So you could have converted the wind into kilometers per hour and did this calculation, but your answer would have been in kilometers per hour.
But then will they accept kilometers per hour as an answer?
Yeah.
That's the unit.
Unless it's specified that your final answer must be kilometers per hour or something like that, then you would do that. But this units here would be the easiest to work with because of the size of a number you're working with.
0,
right?
0 something.
Yeah, because now when you start, see if you look at the number 10 meters per second, right? If you convert that to kilometers per hour, you're going to end up with 0.00. And then if you convert that kilometers per hour into meters per second for something else, you're going to end up with like 150,000 that you're working with your numbers.
To make it simple, this is convert everything to meters per second. Right? Standard units.
If the question tells you in meters per second. If the question tells you, like how the first question was, kilometers per hour, just stick to kilometers per hour and just work.
Because conversion will take up time. And you can mix it up and then
but again, you said a conversion might actually be one walk.
But it's depending if they want you to do the conversion. Like see here, I needed you to do the conversion in order for you to carry out the question. Guys, are we all okay? Don't you know this can't while you're overthinking things here. Stop overthinking things.
Experience makes you do that.
No, don't overthink it. See the question itself? Every single thing we did here, you learned. Agreed? Horizontal components, vertical components, the sum of it. Theorem of Pythagoras.
Yeah.
It gave you, remember?
Because one was kilometers per minute.
Wait.
It was 300, so 300 kilometers in 50 minutes. So when you convert it there, you got kilometers.
Yeah. That's what it's converted.
Yeah, that's what you're looking at, isn't it?
I made a mistake.
Oh, we have that part.
No. So when I got to that VA sine of the angle, two there, I had VA sine of the angle and VA cos of the angle. But now I thought the resultant will be the VA squared plus VW squared. And I wrote that out and it just didn't make sense. I messed the whole thing up, yeah.
If you wrote this part down, but you were able to see
I didn't see that what you had there. Yeah. I didn't see that VA.
Yeah, important to know this, guys, because a similar type of question is coming out in your test. So make sure you understand this. Right? While I'm here, does anybody have any questions on this? On how we got to anything? Why we did what we did?
Okay, question. It's just that we didn't do it like that, right?
Which part?
On the second the sum, yeah. What if you convert it? You converted like you did it separately first. You did each one separately.
Each component?
Yeah, each component separately.
Like where you showed VW sine theta equal to.
Yeah, that's right. That more is how I did it separately first. And then I took the calculations.
Because you would have said your one like for this vertical component you would have said VA along your y-axis. This one here you would have said VA along your x-axis.
That's more or less how I did it.
Yeah, that's fine.
That's still fine.
Because you just did like the extra step. Because you would have done that bit first,
Yeah.
then you would have came to this part here.
I would come to it and I took that modus as the answers only.
Yeah.
Yeah.
Yeah, because you would have just substituted straight.
Yeah, substitute.
That vertical component plus that vertical
Yeah.
component. Yeah, that's also fine. If you feel like that, but my only thing is that the more steps you'll do, the less time you're gonna have because you're obviously doing more to get to it, right? Okay. So question 2 wasn't so bad. We all could have solved
No,
it.
but it's simpler when you say it.
It's not that easy.
But you know something? You all told me the answer.
See, when you were reading that question firstly,
Right.
it seems like I can't write.
Yeah.
It's gonna be a VA.
Yeah.
Because you sounded like it's.
That was the catch basically. Even me to first time when I answered this question, I also thought the same. I'm like, but how can it be VA when they're asking me to work out VA? Right? That's where that word destination was the one where you would have to realize that you're going, that's where he wants to be. And that will be your result.
Can you be honest to us?
Yeah.
When you first did it, you worked it out, you got it wrong, you went and looked at the solutions, and you read it.
Now I never look at the solution,
You're
but
honest, yeah?
I did do it like I started working it out, right?
Yeah, okay.
I worked it out and I'm thinking I got stuck somewhere there, I'm like, but what am I working out, right?
So that makes
Then
sense.
I got stuck and then I was like, no man. Then I realized no, what they gave you was the results. Then they asked you to work. Very rarely that they make a mistake in how they ask you a question. Right? They may make a mistake with the number that they gave you or maybe a direction, but it's very rare. What they give you, if it seems like a trick, it is a trick. Right? So it means that you need to think and apply a bit more and work it out. Okay. Sure. Let's answer the next one. Can I take this from me out?
Yeah.
Right. How are we doing on time again?
20 was 10.
Oh shit.
So you took 1 hour 20 minutes to do 2 questions.
Is that my fault?
No, but
Just letting you know.
he said beat every more answers, so technically beat it.
In 1 hour,
20 minutes on 2 questions.
True, that's true.
3 questions actually. The definitions. This year and that's it.
That's not bad.
Come on, guys.
Yeah.
We're good at this now.
Beginning.
And also, you're not lighting in this room, actually. Yeah?
Oh my
Where is that?
Where you have one desk for yourself.
There you go. Okay.
Is it? Okay.
Oh, yeah.
In room 5.
Oh my goodness.
Then you give your one desk for each person. It's a test room, you have to.
Yeah.
Okay, let's look at this question here, right? They tell you a bullet is fired at an angle of 33 degrees to the horizontal. So this is a bullet. It's fired at 33 degrees to the horizontal. We know that bullet will probably go there, right? The velocity is 410 meters per second. This here is positive, this here is positive, negative. Right. Calculate the following. The maximum height reached by the bullet. Right? So, okay, so this means that our gravity is equal to minus 9.8 1 meters per second.
Yeah. I have a question on that. So in the data sheet it says 9.8.
Yeah.
And you saying
Minus
you always use 9.8 1 in the past. So when we're doing our calculation, we also use 1 in the data sheet, isn't it? So it's also plus the 1.
Yeah. But I think that's probably a made a mistake.
That dot sheet is.
No, the exam, all the standard ones say 9.8, not 9.81.
So all these constants, you follow what they give you in the sheet, but they're not so fussy about like if you use 9.81, because they also know that that is the constant up to 3 or 2 decimal places. They maybe give you up to 1 decimal place. That's nothing to, don't be concerned about it, right? Okay, but I'll go adjust it for just before. So there,
So you put it back to
that's 9.81, right? Is it okay?
No, either one is fine, but
Yeah,
we need
just to
be
be
aware
sure.
that we use the one that's in the
Or what they tell you.
Yeah.
They tell you use G equal to 9.81. Am I fine?
Yeah.
Good. How will we answer this?
So when we calculating the maximum
So you
height,
write what you got first,
Yeah.
all the information you have.
What information?
So you got
you got U,
which is 410.
410, and V, which
V
is
is equal to
0.
0.
Your G is
minus 9.8.
and then you're required to work out
Yes.
S on the y-axis.
S is equal to V squared minus U squared over 2G.
Yes?
0 squared minus 410 squared over 2 into minus
9.8.
No,
minus
it's wrong there.
9.8.
Don't you have to work out the
Minus.
vertical component?
Yes.
Yeah.
So this is wrong.
Oh, yeah.
Right?
So that's why I said S on your y-axis.
Right.
So for height, you need
So-
to work out your vertical.
Right.
Right.
So for height, you would take the vertical component of your velocity, because remember your velocity is being fired at an angle. Right? Right. So this here is your vertical component, this here is your horizontal component. So the velocity of your vertical component will be equal to U sine of the angle. Velocity of your horizontal component or initial velocity is equal to U cos. Right? Not like I never saw this before. This is how we normally answer it, right? So, first thing you would say, U of the vertical component, which is your initial component, is equal to U sine of your angle, which would be 410 sine of, which is
223.302 meters per second.
right. Yes? And then after that, what you do?
Then you work out
Then you work out
this
your S.
Then you work out your S, right? So you say S for your vertical component is equal to V squared minus U squared all over 2 times gravity, which would be 0 squared minus 223.302 squared
over
2 times negative 9.81, which is
129.80.
Just checking on something. Right? Yeah, I got the answer, right?
I don't have an answer.
I have the answer.
that's a big number.
It's a 25, 2544.025.
It's 2544.072.
Yeah. What I'm saying is, you took minus 9.81 as your gravity, right? But in your directions, right, you took positive
as up,
right? This is your height. So shouldn't that the bottom one? I know that doesn't matter with distance, right? But shouldn't that be positive 9.81 going up?
But gravity is going down. right?
Gravity in
Gravity is
general
always going down.
is which direction?
Down, positive.
Yeah.
Now,
negative.
these positive is up and negative is down. Like,
So anything moving down is
Yeah, but your direction is showing positive up. Shouldn't that be
Yeah.
9.81 going up?
No,
Gravity actually which
is for
direction?
the gravity, which is pulling. It's pulling down.
what
Which-
makes
which-
it down, up?
which
The
direction
positive
does gravity
is
always
going
act in?
down.
Down. What I took down as?
Negative.
So the gravity value will always be in this question. Eh? If I took down as positive, then gravity will be positive. It's exactly like our kinematics question. Anything is moving up, positive, anything moving right, positive, that's all. So that's why gravity is a negative value. Because gravity is acting down, we took down as negative. Okay? Fine. Right. Then, 3.2. 3.2, they want to know
the horizontal displacement when the bullets hit the ground.
calculate the horizontal displacement with the bullet hits the ground. How do we do that? Chema, you okay there?
I'm trying to find out something.
What's going on? I'm here to work on whatever issues you have for Saturday. You want her to come on Saturday and say teacher never teach.
Yeah, I'm getting 251. How are you getting 254? 2544.
Calculate, sir.
Calculate it again.
Calculate again. See.
Let's see a calculation. No, don't do it like that. Don't do it like that. Because see, when you do it like that on a straight line, right? What you basically did was, so tell me exactly how you pass your calculation.
You divided, I think, the division on the 2.
Right. So you did 223.302 squared divided by
Let's put brackets in.
2 minus 9.1
squared.
H.
Oh, sorry, yeah, no, squared, yeah.
Nice.
Yeah,
see, when you do it like this without your brackets, right?
Let's get the 9.81 first, then multiply by 2.
Yeah, so what it does is it divides, see BODMAS rules, right? It would work out your brackets first. Maybe I'm just trying to create this thing for you. Oh, also, you know, with the negative sign.
Right.
By 2, 2.
Minus on the top.
There's a question.
It's the same thing.
What do you use?
It's not the same.
The only difference will be the
it's not the same thing. It's not the same thing.
What?
That's not the same thing.
The only difference will be the sign. But what I'm saying that the answer will be the same, but the only difference will be the sign.
What's the answer?
There's a question that if you use the horizontal
2541.
cos theta, right?
That's what I'm saying. I'm getting 2541, but you're getting
2541 point. That's what you got.
Yes.
That's
right.
Yeah, you got 25444 there.
Someone used another.
Oh no, you know why? Because I took 9.8, not
9.81.
It's
just a decimal.
If you use
that's yeah, you still get the
if you use 7,
yeah,
the horizontal component,
No, I had 251.
Work out this.
No, if you calculate the horizontal component first,
2541.
and to get the vertical, you use Pythagoras, right? Could you do that?
Yeah.
But the answer is not exactly the same. I got 224 instead of 223.
You know, you use 9.81. I mean,
he used 98 only, not
yes,
but you took it as 3 decimals.
That's why we got it.
Yeah, I got 224.
See, if you took that, you know the value for the arcs.
So say for instance
so you would have said 410 squared minus.
No. So what I did was the u cos theta, right? Came out to 343, right? That's the horizontal one. And then I used the other. It came to I squared it, and then it came to 224,613.
Right.
And then I used it in the same calculation that I did for the displacement. Came to slightly 2567. But then I don't know if the workings are similar. Just at the
this came to 2567.
No, the bottom one.
Yes?
Yeah, because the top one was 224.
Yeah, but basically because that's of your decimals. Now you see how your decimals can mess up if you carry on with the long.
Yeah, but this using 9.81 and 9.8 makes a big difference in the numbers.
Yeah, that's how I got 4.
Yeah.
But we mark on a, like I said, we mark on a range.
Yeah.
Right? And remember something, right? In this questions here, like we said earlier, if in the paper, if they give you the gravity constant as 9.8, use 9.8. If they give it to you as 9.81, use 9.81 because the answer is going to come on how that's the constant they use, that's how it works out. Your question was, you use this here to work out the velocity, you use theorem of Pythagoras to work out this one.
Yeah.
Because of the decimals,
Yeah.
it throws your numbers off. Because remember, you took 3 decimals here, right?
Yeah.
Then when you took your 3 decimals here, you solved for this value here. Already it's going to be a different, slightly off because of the decimals. Then using that there, when you come to this part here, you saw how the 9.81 and the 9.8 made a difference of like 3. When you use the different value there, it's going to come.
Would it be wrong this, or would it still be acceptable?
You get half marks. You get half mark instead of 1.
You see, no, it depends on how the examiner is, the person marking your paper. Right? Because if they look at it and they say, okay, you took it there, like there, they'll say, but firstly, it took a long way to come to the same thing.
Yeah.
But they won't say it's wrong, but they may give you the marks. It depends on that person who would understand.
Alright.
Right? But yeah, okay. Are we okay with this? How we answer the second question? 3.2?
So I worked out the time first, and then I had one more, and then I worked out the straightforward velocity.
Let's work out the time first. Horizontal.
Okay. So what time are we working on?
Half the time.
Half of the
from the
full distance.
Get to.
I know the say it properly. Say it properly. Why are we working on the time? Well, and what time are we working on?
So you're working on the time for the bullet to take till it reaches the
maximum height. Okay, so we're working out the time taken for the bullet to reach maximum height.
Yeah.
Which is the same as the time that it will take from maximum height to the ground.
Yeah.
So you know it's twice the time it takes from start to finish. Basically, yeah.
Right? So what he said was the time taken to reach horizontal displacement is twice the time taken.
Now do you have to write it down? Right?
No, I'm just saying it for all of us. So
okay, so we can just go.
Time taken to reach maximum height. Yeah. Right? Which is why the first thing we're doing is working out the time taken to reach your maximum height. Which formula would you have used?
For the time.
For the time?
V equals U plus T.
What? Hey, this V is for your vertical component.
Yeah.
This initial velocity is for your vertical component. This time is for your vertical component. Right? This V is equal to 0. This U is equal to
223.30.
223.302 time plus negative 9.81 times time. Right?
Yep.
You take this across, it becomes negative 223.302 divided by negative 9.81, which is equal to your time. And then this time is
22.786. But I use 9.8.
Yeah, that's fine, that's fine.
So it will be slightly different.
It's fine.
22.7.
88
No.
Yeah.
with the 9.81.
If you use 981, it's 22.76.
76?
3.
Okay. It's fine. Right? Okay. So, therefore, your time taken for your horizontal component is equal to 2 times 22.763, which is
45.5 seconds.
45.5 on the dot.
I have no idea. I can't remember. We're not tidy.
You can't read it, right?
45.526.
26 seconds. Right. Now we know it's the time taken for you to go from here to here. We need to work out that. Right? So your initial velocity along your horizontal component would be equal to initial velocity cos of the angle, which is 410 cos of
33.
33, which is
343.855.
85?
855.
Probably the 9.8.
Yeah, when I penny,
Oh no, there's no 9.8 thing over here. This is good.
No, but they rounding off. When you round it off, then you're gonna round it.
It doesn't. Even
There. Now, your displacement. There? How would you get that? What formula would you use?
Well, V times T.
Is equal to?
V times
It's going to be initial. Remember this formula here is this S is equal to UT plus half GT squared.
Yeah.
But remember this part here falls away because there's no gravity component on your horizontal, right? So we just end up with that. So in terms of notations, this is your horizontal component, this is your horizontal component, that's your horizontal component, right? This would be equal to 343.854 times 45.526, which is
15670.16.
right? Did everybody get that? Yeah. You know, you got that? You got that? Which part you got?
You're not paying. Where are you getting this answer from?
Guys, right?
I'm not getting that.
Why are you not getting the answer?
I got 15654.297.
15654.
Yeah.
Why? Because you it's fine. That's just.
That's not get too good.
Yeah, you're over the. I need you to know method.
See, the thing is, what he's got there is wrong.
Where?
Because 15670, it's 15654. So now, what if you punch those numbers?
Okay.
If you punch those numbers there on the calculator, you're not gonna get that answer.
It's fine, whatever it is, it's point was.
Yeah, because you see when you're rounding up the top one, rounding up 3 decimal places
is 855.
855, not 854.
Yeah, it's 855.
That's it. See that one?
Remember,
Over
the thing
here,
is,
here it's
855. Yeah.
5. So put in your calculation out, Jama.
Okay, now it's right.
Like, are we all okay?
Yeah, see, even that same would be, I said I did the U cos one.
Yeah.
You did it there anyway, so.
Yeah. But see, when we remember I told you when I was teaching it that for height, you look at vertical component.
Yeah.
For displacement, you look at
No, what I was saying is that I did like, so, I guess in a way.
Yeah, you're okay there. Where you
No, the projectors are now confused.
Ladies, is it okay? How are you being attacked?
The answer is still wrong.
Whose answer?
That's the answer.
Why not?
It's still wrong. 15653.999. That's the answer.
okay, that's the answer, guys. Right, let's move on to the next question.
Remove the answer, please. That one is wrong.
Just a piece of table is good.
You're so angry, I don't know what is this. Right, Chema, what's the right answer?
15653.
15653.
Point triple nine.
Point triple nine.
Yes.
That's all.
Yeah.
Does this make you feel okay now? Are you okay? Are we good? We're
Hey,
still friends.
Yeah.
You sure you got the calculator in the right mode?
Oh, yes, you're on the go. Watch the YouTube videos on how to use a calculator.
Guys, time, guys. We need to finish up this.
That's fine. It's fine. It's fine.
You got the answer, Jackie?
Yeah, my answer is 15,670.157. When you look at my calculation, you will see how I got to that because I didn't show this part here. I just included it when I came over here. Right? I just said 2 instead of showing 45.526. I just said 2 times when I worked out.
Oh, 526.
Yeah, that's all. Right?
You already said. You
I heard it. As he said that, okay. Oh, 526 more. That's it.
That's right, sir.
Students who are watching the video,
Yeah.
my students need to learn how to use a calculator.
Just put his face there so
Yeah, and I'll show you specifically who it is after this.
Just now you're gonna end up, we're gonna say, let's get a bullet, you run and see.
Yeah, we catch it. Then we'll work on the exact distance then. Okay, let's do the last one.
Two vehicles.
For kinematics. Right. This question, y'all are solely doing it. Right? Whatever y'all tell me, I am gonna write it in the board. Right? If you get stuck, I'm gonna let you. We're gonna go all the way to the end. Then Jamba and all can tell me whatever decimal places there. It's fine. I want to see how you answer this question like you would answer it now in the exam.
It was a union, that's why.
Don't worry.
It's union debts are the one day. Why do you fight for everything? Right. Who would like to volunteer to read the question?
Two vehicles start simultaneously at the fork in the road. Vehicle A travels northeast at 90 kilometers per hour and vehicle B travels west at 110 kilometers per hour.
Okay.
Calculate the velocity of a vehicle A relative to the velocity of a vehicle B in magnitude and direction.
Okay. Watch out, me do first.
Draw
Cartesian plane.
Cartesian plane. And everybody has to contribute, huh? Because not like one person answers all the right? Cartesian plane, there. Now.
Northeast, vehicle A is equal to 90 kilometers per hour.
Left. Left.
Yeah.
Left.
Travel west, straight line, 110. Vehicle B is equal to 110 kilometers per hour.
Left.
The directions.
Directions.
Required to prove velocity of A relative to B. Then what we given first. Vehicle B relative to the ground along the x-axis is equal to -10.
I think before you go there, let's put in the angle. We're not given the angle for vehicle A.
Oh, yeah.
Yeah.
Okay. What angle you put?
45.
45.
Okay. Next.
Go.
I said not only one person is asking, yeah?
Okay. And then.
Okay, wait, let's start. Okay, I'll wait a second. What would you do next?
After this? Okay, we need to find the vertical and the horizontal components of vehicle A.
Vehicle A, right? So how would you find it?
To say
the velocity of A.
Wait, I need to make sure everybody in the class understands what we're doing. You're not Nari or anything?
No.
A is equal to velocity of A relative to the ground on the x-axis equal to velocity we need to get it on. Okay, it's gonna be.
Did you try this question?
No, I didn't try this one.
Why?
I was stuck on the previous.
You just did the
On the previous one, so I couldn't continue on that.
There's another thing, right? In a test or in an exam, if you're stuck on something, right? If you're like spending longer than 5 to 7 minutes on it, and you're just dead stuck, you can't do anything about it. Move on to the next question, answer, and then when you finish answer or everything you know, then come back and tackle it. Don't waste time for 20 minutes trying to solve something And then when you come to the parts that you actually know you only have 5 minutes to answer 7 questions, that you can actually bag marks on that. Very important for time management skills, right? So from this point here now, what you do after that? So you told me you're working on the velocity of A relative to the ground along the x-axis.
Yeah.
Right?
Yes.
How do I work that value out?
Gonna use cos.
You're going to use cos.
Yeah.
How will I use cos in this?
I'll say 90 cos 45.
Okay. Everybody stand with that?
Yes.
Everybody agree?
Yes.
Right? And what's that?
63.639.
Zama, what do we do after that?
Velocity of A relative to the ground along the y-axis.
How you get that?
When I use sine
Yeah, but first,
90 cos 45.
Cos?
90 sine 45.
equal to 63.639 meters per hour. 61 after that. See, now I'm telling her to speak, now she doesn't speak.
Oh, see.
Oh, I didn't see. Okay, velocity of B relative to the ground along x-axis is equal to 110 kilometers per hour.
Would it be minus 100 here?
Yes, minus.
Yeah. Minus.
What are you saying? Yeah, I'm just writing what you said.
Let's be all the
Velocity of B relative to the ground along y-axis is 0.
Everybody agrees?
Yeah.
So far we all good? Right, so what should we do next?
Unless it's a trick question and then we are getting it wrong.
But so far everybody is confident about what we got.
Okay.
Okay. So what should we do
So
next?
you work out the velocity. Right, so velocity of A to the relative to B on your y-axis is equal to velocity of A.
You're the first one that I know.
To the velocity of A to the ground on the y-axis plus the velocity of the ground to B on your y-axis.
Right, Bilal, what you do after this?
Velocity of A relative to the ground on the y-axis minus velocity of B relative to the ground on the y-axis.
Why we did this?
We're getting the y.
No, why we did this?
We want B relative to the ground on the y.
We want both terms
So
relative to the same
same
factor,
thing.
which is the ground,
Yeah.
right? So this value here is this 63.639 minus 0, which is 63.639 kilometers per hour. Chamba, my good friend, what do we do after this?
Wait, he's still calculating to check
Yeah,
out this.
you're happy with the decimals, right? See, you know why he's calculating. 6 times 3 is 24. Now somebody else did a math.
Actually 647.
Yeah. I didn't want to say anything because
Don't
you
be-
guys were gonna challenge me.
Okay,
Yeah.
okay. We're not gonna argue
We're not
about
gonna argue
decimals.
about that.
Right. Chamba, what you do next?
Calculate the velocity of A relative to B on the x-axis.
Velocity of A relative to B along your x-axis, which is?
Velocity of A relative to ground along the x-axis.
Yeah.
Plus velocity of ground relative to B along the x-axis.
And it will be the same like how we did it here, right?
Yeah.
Velocity of A relative to ground along the x plus, no, minus velocity of B relative to ground along the x. And you're substituting, this will be 63.639 minus 110.
Yeah.
Yes? Right? And what you end up with?
173. 169.
Right? Well, now we are at this point. What would you do now when you're here?
Theorem of Pythagoras.
Oh, your name is what?
My eyes are facing down. I didn't.
I'm playing.
Okay, just take our answer. Yeah, it's okay. But seriously, okay, after this point here now, so we worked out our vertical components, we worked out our horizontal components. For what?
For the X and Y axis, for angles, it should be.
So now what would be your next?
I use particular result.
Right.
Your relative velocity,
Yes,
right?
yeah.
How am I doing that? Seriously, I don't know if you're joking or whether you're being serious.
No, I'm serious.
Okay.
Absolutely clear.
How you worked out number 2 and you passing this one?
Okay, Nikki, if you were at this point here, what would you do next?
I'm gonna draw your put your figures in, draw your new Cartesian plane.
Okay, draw a Cartesian plane.
Maybe I was drunk then.
I'm telling you. Right. So, how would I substitute my values here?
You're gonna put your y axis 63, 639 positive, so it's on the top.
Right.
And then your x axis is 173,639 to the left.
Left, right.
Sorry?
To the
The
left.
x. No, to the
173 is
positive.
Positive 170.
sorry, to the right. I'm saying right. I'm doing this.
Yeah, whatever.
Okay, so this is 63.639, 173.639. Then?
And then you're going to draw your resultant line.
Okay, so.
And your triangle for Pythagoras.
Right, so this is what?
Positive B.
Right. And then this is?
That's your angle.
Right. Now, I'm coming back to you now. Did this refresh anything?
Yeah.
So what would you do next?
Now you need to work out your the value of A relative to B and also your angle.
Right. So how would you work out the V of A relative to B? Right. No, I mean, what do you want me to write here?
B A B squared is equal to 173.
No, I want the formula.
Formula. The BABY squared plus BABX squared is equal to 173 squared. The square root, take two square roots of 173 squared, 173 plus 639 squared. And then you try some.
184,939. 184,935.
What would you do after this? What do you got?
Use 10.
Use 10.
Yeah.
So tell me how I'll read.
10 equal to
10 of the angle there
Yes.
equal to
VA BY over VA BX.
that. So here you say angle is equal to shift 10. This value here is 63.639 all over 173.639, which is
20.128.
So you see that?
Therefore, VA relative to the B is equal to 184.934 meters per second per hour. Per hour is 20.128 knots.
How many months? 5?
Maybe 6. Because you showed the negative there.
That question took us 15 minutes.
Okay.
That one would be that if you drew a line from there, from A to B, that would be the last place.
If you draw the line.
Yeah, first day.
But then this specific means if you are standing at B, where is A from B?
Okay, then that's the angle also.
Yeah. So A is northeast.
Okay, that's
Yeah?
And B to A with the direction.
B to A
would
will be
the same.
southwest.
Just be the direction change. Yeah.
It swaps the magnitude will be the same. Guys, we good?
You can stop question.
So I did it. I read the question properly, so I did it as resultant, not relative.
Yeah, they did that to the other day.
But I got the slide, the second one first. Okay. So also, I didn't change the sign. It's not going to be as it should. So I don't know if I want it. So short version.
Yeah.
But this is the same thing. It's just that you just didn't say ground. Because see here, you said B of A relative to B along your X. B of A relative to B. You just never put the ground.
So I didn't do those steps.
So you did do relative, but you just never made it relative
So I didn't
to
do
ground.
that. So would this now be wrong because I didn't put that step to show the change
No.
of minus.
So when you get marks here, right? You get.
But you know why that answer came up again? She took, she made a plot in the top.
Yeah, the
she
top
took
was
110
negative
as
and
positive, yeah.
Yeah,
That's
so
what
it
you
is a
mean.
positive.
That's
But
what
your answer came out
mean, right?
exactly the same.
Exactly.
Exactly the same. That's the reason it came exactly the same.
Yes.
Oh, but you know why it also wouldn't have mattered there? Because see, here, the double negatives made it a positive. So that's where you already put a positive over there. Yeah. Okay. But yeah, where you get the marks here is.
Wait, Jafta. She took 110 going from the left hand
It's right,
side.
because even though you initially put it as minus 10, it came out as a positive 10.
Because of the double negative. That's not in every scenario. I'm just specifically saying here, because the double negative made a positive. But when you get the marks here, is maybe you get a mark for the showing this cos and sine thing, but like that's one whole. Probably if I'm feeling nice, I'll give you a mark for showing the negative there. Give you a mark for working on the vertical, the horizontal. For this, and then for giving me your final answer. So like 7. But this one, and sometimes you'll see like on the moon that whether we're giving that, right? But
You got a genius in the class.
right, are we good then? What's the 10?
10. I say 11.
Not a meeting at 11:30, but
I just
you have to do this tomorrow. Or?
Let's continue.
This will be quicker.
Okay. Okay. So the class answered this question. You okay?
Are you happy?
I don't know. I'll tell you on Monday or Tuesday. Right. So I can take it. After you read Saturday, I must mark. And also after class, not even here. 4, 5, 6, 7, 8, 9. Okay, not after class. There's 4 people not here.
Yeah.
Kaya, the 2 Supermandas.
And Togo.
Yeah.
Are they still even?
I don't know, because I've never seen them in my class.
Yeah, there's a lot of just shovels. Gears like these.
Nobody came last time.
Yeah.
No, Kaya, you must see
Yes, other two that joined late, so I'm not sure what's happening. They only came that, they only came once.
Okay, let's do this, right? A turbine in an electrical plant has a diameter of 6.5 meters, right? It's rotating at 750 revolutions per second. The turbine slows down to 500 revolutions per second. The time it does this is
45 seconds.
45 seconds. Can determine the angular deceleration of the turbine. What? Okay, our units, is everything fine then? Don't need to do any conversions. So, what formula you would use to work out that?
A 2 pi n1, n2 minus n1.
2 pi n2 minus. Right. So you substitute 2 pi 500 minus 750 all over 10. No. 45, which is?
Minus 27.925.
Minus 34.907.
Yeah. 34.907
radius per second squared.
Radians per second squared. And remember your number came out to a negative number because it's decelerating. It's slowing down. Okay.
This formula, we always use that for angular acceleration.
Yeah, this
and
yeah.
The formula sheet uses an A.
Yeah, because they can't, the people who ever typed it out couldn't find it. Right. But this sign is alpha, alpha is your angular acceleration. Okay. 1.2. Calculate the number of revolutions completed during this deceleration. How would we work that out?
The average.
You're laughing like
The average.
You'll work out your average, right? So, you'll say n average.
That's I was still wondering why they gave us an average.
Yeah, also wondering.
Yeah.
You don't.
We never used it.
Right? N1 plus N2 all over 2. This is 750 plus 500 all over 2, which is
625 per second.
revolutions per second. So what does that tell you? That tells you in 1 second there's 625 revolutions. Right? Remember the complete duration for deceleration is 45 seconds. So in 45 seconds you're going to end up with 625 times 45, which is
28125.
That's all.
Revolutions.
Oh, revolutions. That's all.
Yeah.
That's it.
Yeah.
Well, I could therefore that many revs during deceleration.
That's right. Good.
Yeah.
Right. Number 2. Calculate the rotational frequency in revolutions per minute of the wheels if the train moves at a velocity of 280 kilometers per hour, given that the diameter is equal to 720 millimeters. Right. Tell me.
Before you go on, right?
Right. You look at the memo.
Remember, I did exactly like you.
I don't. I also probably there was an error out there said because if you look at the way they worked it out, it makes no sense whatsoever.
They divided
right?
by 2. Where they got? They use W is equal to.
That whole thing didn't make sense to me.
Which question?
This one, yeah. I know what you're talking about because it doesn't make sense at all, right? Just see that.
I did like a simple like how you do
Yeah.
this. Yeah.
This is how we do it. You work out your average number because there's 2 different speeds. You show how many in 1 second and then you multiply by that.
Okay.
That's it, right? This question. What are they asking you to work out?
Rotational frequency.
Okay? So you're in, right? So they want you to work on it. Given these 2 things, right? Also, your n must be in what?
You see, that's
That was for
that's per second.
days per minute.
But
That was for
that's
days per
1 minute.
minute.
Okay.
Right? Okay, come back to that, right? Given these 2 things, how would you work it?
You need the angular velocity first.
Right.
So you use the V equals W or because you got the radius and you got the.
Right, but
But they gave you linear velocity. They gave you the linear velocity.
Same thing she said.
Okay.
She's saying V is equal to WR, which is your linear velocity is
yeah.
equal to angular velocity times your radius. Right?
So
what you need to do first, man?
So as you mentioned, you need to work on
You need to convert. What would you convert this into?
Meters per minute.
Convert to seconds.
seconds. I could
Right? At the end, you can just give
Yeah,
it.
that's what I did. I
Right?
did everything.
So you say velocity is equal to 280 kilometers
Just convert everything to normal
per
minutes.
1 hour.
Yeah.
Yes?
Yeah.
Right. Okay, so 1 kilometer is equal to 1,000 meters. And 1 hour is equal to how many seconds?
60.
3,000.
Seconds is 120.
3,600 seconds. Right? You could either say 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. Or you could have just said 1 hour is equal to 3,600. So if you were writing this out or putting in your calculator, you would have said 280 times 1,000 all over 60 times 60. Right? Which is 4,666 meters per second.
No, man. Sorry.
That's 77.7.
Yeah, it's in 7.7.
77.8.
That's
778 meters per second. That diameter is equal to how many meters?
0.36.
No, the diameter in meters. 0.720 meters. You understand how we got that, right?
So the radius.
1,000 millimeters is equal to 1 millimeter. 1 meter. Right? So the radius given these values would be half of this, which is
0.36.
Right? Fine? Fine. Now you know the formula: linear velocity is equal to angular velocity times radius. Right? So this 77.778 is equal to angular velocity times 0.36. You divide here, you end up with 77.778 divided by 0.36.
You get 2.16.04 rads per second.
2.16.
0.04. Oh,
216.
0.045 radians per second. Now using that, but
you say you work the rotational.
okay, I'll work it out.
Is
W is equal to 2 pi n.
2 pi n. So 2. Why do I write it? 216.045 is equal to 2 pi n. Therefore, n is equal to?
W over 2 pi.
Yeah, but I was asking.
34.38 revs per second, right? But you need to convert that to revs per minute.
34.38?
Revs per second? I don't know. I don't worry about I just fill the.
In the test,
In the test,
on your
that's what
instructions, it says round off your answers to 3 decimal places. Make sure all of you will do that, right? Because in exams and stuff, they mark it wrong when you don't give it to it. 385 revolutions per second. What they asked it for? Revolutions per minute. So all you'll do is you multiply that by 60. You understand why we do that? Okay? So this answer here is approximately
2063126.
Converting not to revs per minute.
Everybody find it?
Okay. So that's the final answer.
Right.
But the right method I forgot to convert to 80.
It was just easier for me to just keep it in the
Beginning? Oh, you just carried on with previous power. But then
you
you get the end, what your
look at the
answer?
you convert it to. No, it won't work
No,
out.
it won't work.
It won't work out because your formula is
Yeah.
you need to have the right
To get it, you need to have it in meters.
meters per second. Yeah. That's what I always say. Sometimes you just put the right units.
Put it here.
Yeah.
Okay, let's do this last one. The speed of a flywheel increases Why did I walk away from the sheet? Increases from 444 revolutions per minute to 2840 revolutions per minute, and the time is equal to 0.58 minutes. Calculate angular acceleration. What should do to these numbers? Control
That's the
reps per second. So this here would be equal to what?
7.4.
Reps per second.
That's what? 444.
No,
So it's just 7.4.
Just 4.
Okay.
I thought there was more stuff here.
7.3.
That's a 5?
7.3.
47.3.
3.
And then this one?
34.8.
Yeah, 8.
Right. So for this one here, straightforward, you just do it like how you did that. You'll say 2 pi n2 minus n1 all over chat. This would be 2 pi 47.333 minus 7.4 all over 34.8, which is
7.20.
3.
Why did you say it? I'm waiting for you. Somebody 7.2.
203. Yeah, I just put it.
210.
Yeah. Right?
Yeah.
Right.
You need to work on that.
Number of grams.
Right. So you say exactly like how you did that one, right? N average is equal to N1 plus N2 all over 2. 7.4 plus 47.333 all over 2, which is
27.351.
Please 6.
What happened to you? But it was quite clear. It's not calculating.
Please 6.
hey, this guy. Revolutions per second, right?
Yeah.
So we know that in 1 second,
27.3.
1 second you get
You get
27,367 revolutions, right? So in 34.8 seconds,
952.
you're gonna end up with 27.367 times 34.8, which is equal to 9.
5.
But how you would write this answer out, right? After this point here, can you get 952.354 revolutions? You just round it up, right? To take into account that one. So you'd say this is approximately 953 revolutions. Right? So, everybody ready for the test on Saturday?
No.
Yes.
No.
Nice. There'll also be a question on work
Talk.
and talk, right? It's just talk and work I tested you on. Hint for or tip for that one, remember how to convert from degrees to radians. Okay? Remember pi is equal to 180. So
The value of the calculator.
I don't know how you do it, and then remember your formula's way, torque is equal to force times the perpendicular distance between the center point and your working line. Right? Yeah. The only thing I worry about the question is, they mention an angle, right? It's not the angle at which the force is being applied. Remember for the work formula, when I told you when you turn the spanner and they tell you that the spanner turns for 60 degrees, that's going to be your you know the formula for work where you have torque times the angular displacement? That's going to be your angular displacement, which is why you convert that angle into radians. substitute radians.
We did an example of that.
We did do an example on that. It's on page. Can somebody give me the textbook, please? Thank you. Example 2.5, right? Similar to how you did B. Example 2.5 B, right? That's it.
What page is
just check. There's only one
When you're
example.
moving from 60 degrees now to 70 degrees. That's what it's saying.
No,
Right?
no.
So you got your angle. Yeah, right?
Okay.
Your initial,
Don't ignore all this, ignore all this. Ignore all this.
It's saying
See this
initial angle
part
was
here?
60 now. Now you're going now
No.
from 60 to
This,
70 degrees.
this means that what you basically did was, oh yeah, see, you're applying the force like this.
Yeah,
right? Now remember, it's
You have to work
you
out
turning a spanner.
You have to work out the burn.
What it means is that you turn the spanner for 70 degrees. That's what that means.
Okay. So it's not that going.
It has nothing to change with it. It's not this 60 now becoming 70.
That's what I thought.
This is the how much you turn the arc.
Okay.
The arc basically.
Okay.
That's the only thing I wonder about. You're all mixing up on the thing.
So this is the spanner.
So use that other formula. So W is equal to theta times something. No, torque times theta.
Torque times angular displacement, right? Which is that arc angle. This
So-
angle that I gave you, we convert that into radians.
We didn't do an example. So
Jesus Christ! I'm just telling you, we did it in 2.5.
We did it on the board.
you did.
Sure, but you did it on the board with us.
I did.
Yeah, I did.
It's the same. It's an exact same one where you would convert into radians and you'll multiply by torque. That will give you work.
Your work. You did 2.5, 2.6, 2.7, and it says do activity 1 and 1
The
and
homework.
3. Yeah, 1 and 3 was homework. So check it out. So if you didn't have that angle of 70 degrees on the arc, right? And it tells you to work out the work.
You'd use that other formula, that 2
Right.
pi torque. I think.
Okay, right. So only time when you move down and you
When they
use the
introduce
angular
the arc.
and you time multiply it by the torque.
When they introduce the arc, because they see like how what the question itself says for B.
Yeah.
How we say
The work done when the nut is turned through an angle of 70 degrees.
see what they said when it's turned through an angle of 70 degrees. Never mention anything about the force being applied at an angle. See like how the first question, the initial part, where they told you the force is being applied at an angle of 60 degrees. It's different to when the nut is being turned through an angle of, because that creates the arc.
Oh, I see.
Right?
Okay, so you work out the torque normally how we did, but you use the torque then,
To multiply by
but that
the
angle
arc.
is in react, so you have to convert that angle to
The angle is in degrees, you have to convert it
sorry,
to
to
that.
that.
That's the only thing you need to know other than whatever we covered. Okay. Yeah, just make a note of it. Remember your formula, your torque is equal to force times radius. Remember this formula for the arc, it is in your data sheet, we are calling the test. And then, yeah, any questions? Is everybody okay? Is everybody ready for my test? Does everything seem easier? Yeah. Okay.
Can you repeat that formula you were saying? The radians, what will the force?